Hi everybody. Today we are going to work on the skill of solving for a variable in mathematics. A variable in mathematics is any letter that takes the place of a number. So in this case, we're going to be looking at a really simple one to start. And so we're going to have the letter P, and we're going to find the value of the P by looking at this equation and using what we call a break apart drawing or a break apart model. And in class, we've studied how this break apart model can show addition and subtraction relationships. So the first thing we're going to do is we're going to plug in the pieces that we know and then use either one of these operations, depending on what we know, to solve for the unknown. And the unknown is P. So let's start with looking at, do we know our total? Our total always goes at the top of the model. And the total is going to be the largest amount possible that I end up with. I do know that the largest amount possible I end up with is going to be 12, because I know that in order to put P and 7 together, I get 12. So 12 is the most I'm going to have. And then down here is where we include the value of the parts that make up the total. And in this case, I know one of the parts is 7, the other part is unknown. So whenever we know the total and one of the parts, we subtract to get the other part. So let's go ahead and take 12, subtract 7, and I end up with 5 as my other part. So now I know that P equals 5. Now I know that if I put 7 and 5 together, I get 12, so now my break apart drawing is true. All right, and we're going to continue talking about this with a more complex problem now. In the next problem, we're still going to use that break apart model, but in this case, we're going to have a subtraction problem that doesn't actually end up being subtraction to solve it. So it's a subtraction equation, but we won't necessarily use subtraction to solve the equation. So let's go ahead and take a look at this closely. I know that I want to end up with 16 as my value, but I'm trying to find the value of W, and I have to take away 72 from it. So I know that the largest amount that I'm ever going to have is W, and I'll subtract from W to get 16. So I know W is going to be my total, my biggest amount possible, my largest amount, my greatest amount. And I know that 16 and 72 are going to give me the parts that make up that greatest amount. So instead of using subtraction to solve this, if I know the parts, I'm going to actually add the parts together to get W as my final total. So let's go ahead and add 16 and 72. And I end up with W equals 88. So my W is my total, and 88 is the largest amount I will end up with. And you could actually even go in and try substituting and seeing if it works. So I'm going to go ahead and erase W and put 88, and then see if I were to subtract 72 from 88, do I actually get 16? Does this actually work? And it does. So now I know my break apart drawing helped me get to that total. By using addition, even though it was a subtraction equation, I needed addition to solve it. All right, let's look at one more example of solving for a variable. In this case, our variable is going to be L. And I'm going to use the break apart drawing again and start filling in the parts that I know. In this case, I know that L and 47 make up 77. So I know that L and 47 are my parts, and 77 is my total. So in this case, I know the total, and I know one of the parts, so I'm going to subtract the parts that I know to get the part that I don't know. So I'm going to do 77 minus 47, and then I get 30. So L equals 30. And I'm just going to double check to make sure that this is correct by substituting that 30 into the equation for L and seeing if it works. 30 plus 47 it does equal 77. So I know that 30 equals L, L equals 30. Okay, so today we'll be working more on this in class, and thanks for tuning in today for solving a variable.